Welcome to Water Supply and Wastewater Engineering course. So this is an elective course for final years as well as third year students. So in this course, we'll be discussing about the environmental engineering sub part, that is water supply and wastewater engineering part. So this wastewater engineering and wastewater engineering comes under environmental engineering subcategory of civil engineering. So here we'll be discussing mostly focused on the water supply, how we can distribute the clean water to household, and as well as how we can treat the wastewater which is produced by the household or industry and before disposing into the water stream. So this course will be very elementary course for civil engineers, because this is one of the primary subjects which covers civil engineering basic aspects. So this is our introduction class. We'll be discussing about a basic overview of this course, and we'll be starting our first topic, that is how we can collect the raw water source and how we can measure the quality of water. So this course is primarily classified or divided into two parts. First part will be deal first few lectures, or first 20 lectures will be dealt with water supply part, and then remaining 20 lectures will be focused on wastewater engineering part. So in the water supply part, basically as a civil engineer, our major role will be to distribute the clean water to the household as well as the industries all over the India. So to distribute the clean water to industries and the industry as well as household, first we have to collect the water. So the basic steps for water supply is as follows. So our first job will be to collect the water from the source, where we have to find out where we have the water source, raw water source. Once we identify the raw water, then through pipes we have to collect the water and we have to send it to the water treatment plant, because the raw water may have pollutants, because raw water is exposed to environment, and so many pollutants such as solids are dissolved, or maybe some pathogenic bacteria are present in the water. So directly raw water cannot be not given to the household as well as industries. So before sending of the water, we have to treat this water. Water has to pass from different filters, and each filter will be clearing or filtering some portion pathogens or some pollutants from the water, and the clean water will be ultimately distributed to the household. So that will be discussing more focusedly on this first part. And then the second part is, once the water is consumed by the consumer as well as the industry also consume the water, they will produce the wastewater, and this wastewater will be discharged through drains, and ultimately it will be discharged to any dumping yard or maybe in a river stream. So before disposing of this wastewater, some treatment also has to be performed, because wastewater may contaminate the water source, or it may hamper the aquatic life in the water stream. So that's why before sending even the wastewater, we have to clean the wastewater as much as possible as per our Indian standard, and then we'll dispose the remaining water. So this course is starting is deals with water collection from the source to ultimately the dispose of wastewater into the river stream. So you can imagine this is the entire cycle. We are collecting the water, we are treating the water, and we are distributing to household. Again, from household we will produce the wastewater, it will be distributed again, it will be treatment plant, it will go wastewater treatment plant, again it will go to river stream. So this is the entire cycle for this course. So today we'll be starting our first unit of this course, that is municipal water supply, that is source and quality. Okay, and this is our first lecture in the first unit, that is raw water source and quality. So let's get started in this course. So as I already discussed, that our first in the water supply, first what you have to do is, somewhere some river will be flowing, right? Some rivers will be flowing here. So our first job will be to locate the river stream. So river stream, maybe from river we can collect the water, or from lakes or ponds, big large ponds, lakes also can be a source of water. So, or maybe underground water also we can collect, we can extract it through pipe, and that also comes as a water source. So our first job is to identify the raw water. So raw water, once we identify it, we have to collect it, right? So these slides will explain the what are the different raw water source available for us. So raw water can be classified broadly into two categories. One is surface source, and then next one is underground source. What is surface source? As the name also suggests, under a surface source means the water which is available at the surface of the earth. whereas underground source is where water is deposited on the aquifer, means underground below the ground, and that water we are extracting. So depending on the location, depending on the availability of water, we may choose surface water or the underground water. For example, let's consider the city of Hyderabad here. So in Hyderabad, the GHMC is responsible to distribute the water, right, to the household. So the source of water may be a river source. So first we have to think of, because the city population is very high, so maybe we have to think of the large water resource. So maybe nearby, if any river is passing, that we have to check it out. If possible, then can we collect it water from the river? If not, then in the city, if there are any ponds or lakes are available, like in Hyderabad we call it a city of lakes. So here so many lakes are available, like Himayat Sagar, Osman Sagar. So these also can be a source of water. So these are actually the surface source of water, like ponds, lakes, river streams, storage reservoirs, oceans. Even ocean water also can be purified and can be used for the domestic purpose as well. But again, the cost of production will be little higher compared to other cases. Anyway, so the surface water, now we understand that the like ponds, lakes, streams, rivers, or the reservoirs like storage river, dams, all these things are basically surface water. Now another type, as I mentioned, is the underground source of water. That means, through rain, water is coming on a ground, right, and these grounds, the water percolates through the ground surface and it deposits on the aquifer or at the bottom of the soil surface. So that reservoir we call it underground source. But again, underground source are limited, but if we extract too much underground water, again it may it may impact the overall ecosystem of the earth. So that's why underground resources are limited. So for these large cities, it is not at all advisable to use the underground water, because underground water will deplete very quickly, and it may impact the overall environmental process. But yes, where the population density is less, there we can use underground resource also as a raw water source, and we can purify it and we can distribute it. Now you can imagine there are two types of, you can understand there are two types of water stream we have. Now these two types of water also will have different properties. Like those are surface water, like pond, lakes, it will have some suspended vehicles, suspended particles will be floating on it. So we have to clear, we have to remove all these things also. Whereas in the underground source, you may not find any suspended or suspended solids, because it is already water passes through the soil mass and it deposited at the bottom. So already the filtering happened through the soil's natural layer. So because of that, the underground source may not have large suspended particles on it, but underground source may have dissolved many hard heavy metals, such as arsenic and all. Maybe arsenic, iron, all these things, heavy metals may be dissolved in the underground water. So treatment process for surface water will be of one type. Treatment process for underground surface also will have different types. So that's why, depending on our locality, depending on our requirements, you have to choose which one is our raw water source. Raw water source, as we discussed, there are different types. And underground also, there you can see there are three types of underground waters are available. One is spring, one is infiltration wells, another is wells or tube wells, wherever we collect the water. So this is about raw water collection, so raw water source. Now in the last slide we have seen actually the collection or the raw water where it is available. Now as we know that the water is so much pollutions are there in the water. Like if you consider the river Ganga, it is one of the most polluted river in the world. So because all the industry outlets are directly going into a river without treatment. So because of that, the quality of Ganga's water is not at all good. Now how we can find it out, the water quality? Because as we are telling that the water quality of river Ganga is not good, but how we are telling, how we can quantify it? So that's what we have to find it out, some experiments. You have to do some experiments of water. First we have to find out what is the characteristics of water, and from the characteristics we find it out different properties of water. By looking into, observing into those properties of water, we can specify that whether the quality is good or quality is bad. So water quality can be broadly classified into three categories. One is physical characteristics, chemical characteristics, as well as the bacteriological characteristics. So what is physical characteristics? Physical characteristics is like turbidity, color, taste and odor, temperature. These are all physical properties. Like, but by physically only we can see all these things. Turbidity means how much solid particles are present in the water. So if the water is so much muddy, means we can see the muddy water. It means that this soils are mixed with in the water. So that's why it is called turbidity, means how much solid is present in the color. If some particles are mixed on a water, we can see the color of the water will be changing. So that also we can see by just observing, physical observation. Then similarly, taste and odor. Odor means if is there any smell is coming from the water. If water is polluted, you will find the bad smell in the water, that we call it odor. Similarly, taste also, bad water tastes different, right? So that's why that also physical property. Similarly, temperature. Temperature means pollutant water may have high temperature compared to clean water, because in pollutant water may have different bacteria which will continuously producing reproducing, because of the temperature of water may increase. So that's why by looking into these parameters we can initially identify whether the quality of water, how it is, good or bad. So these are the physical characteristics of water. Anyway, we'll be not taking into more in details in the subsequent slides. Now, next characteristics of water is the chemical characteristics of water. So in the chemical characteristics, basically we perform few chemical tests, and when we finalize the different properties. For example, first chemical characteristic is pH. How much pH is present in the water? Either it is acidic or alkaline. What is the different types of pH is present in the water? So that we can find it out through these chemical things. So next we have the hardness. Hardness means if the carbonate and bicarbonate products are dissolved in the water, then it makes water hard, right? That is hardness. We studied in the 9 standard class hardness of water. So this hardness of water also is one of the chemical characteristics of water. Similarly, if any chlorides are dissolved in the water, that we can find it out. Similarly, if any sulfates are dissolved in the water, that is also chemical characteristics of water. If an iron is present in the water, or if any other solids is present dissolved in the water, similarly nitrates. So all these major these chemicals are present in the water. So we have to find it out each parameter, and if each parameters are in the acceptable limit, then only we can tell that this water quality is good. Otherwise we have to treat for it. Similarly, last characteristics of water is the bacteriological characteristics. So as we know that water, so many pathogenic bacteria are present in the water. So because many waterborne diseases are happening if we consume the pollutant water. So bacteria's characteristics also we have to find it out in the water. How much level of bacteria are present, what type of bacteria are present in the water. If more number of bacteria are there, then we have to clean it the water, and we have to then only before supplying the water. So all these parameters you have to find it out, and then based on the values we have to choose for different treatment plans. For example, in the last slide we have discussed the raw water collection, right? From where we can get the raw water. So once you collect the raw water, we find it out all these characteristics in that water, like how much is the turbidity, what is the color, what is the taste, odor, all these parameters we find it out. And if some water has more chloride content, then the treatment also will be some other line, means we will have to have chloride has to be removed from the water, or the sulfate has to be removed from the water. So depending on which parameter is more in the soil, we have to filter. So our filter treatment plant also has to be designed such that the appropriate values or appropriate pollutant has to be filtered out from the water. Similarly, if the more number of pathogenic bacteria are present in the water, then we have to design the water treatment plant such that those pathogenic bacteria has to be removed. So now let's see one by one each characteristics more in details. So as last slide we have seen, basically water quality can be classified into three parts. One is physical characteristics, chemical characteristics, and the bacteriological characteristics. So in the physical characteristics we have the turbidity. So turbidity means basically if a large amount of suspended solids are present in your water, it will appear in a turbid, right? So this is example you can see. So this is a clean water, but if you mix mud into the water color will be something like that. So that is more number of soil particles are present in the water, whereas this sample has less number of soil particles in it. So if the large amount of suspended soils are present in the water, it will appear as a turbid, and that's why the name is also turbidity turbidity meter. In the instrument we can find it out, and the unit of finding out this turbidity is, we call it NTU, nephelometric turbidity unit. So originally turbidity was determined by measuring the depth of the column of the liquid required cause to emit. So basically what will happen, so how we can find it out, which what is the turbidity level on a water. Basically what we do at the beginning, we ignite a candle. So candle light will passes through this bottle and a glass jar, and backside it will be recorded, right? If the water is more muddy, then what will happen, the less quantity of candle light will pass through it, and the reflection also will be less at the bottom, at the backside. So that is the, if more number of mud is there, then the reflection or the light transmission also will be less. So based on these properties we can find it out, what is that, how much water is turbid. So nowadays we are using nephelometric turbidity unit, NTU. So this NTU is the nephelometric turbidity unit. This is also passes to similar similar physics as I mentioned. Basically, water light will be passed through these bottles, and depending on how much mud or how much solid is present, dissolved in the water. So based on that, that much light will be absorbed by this, and remaining will be recorded at the bottom. So based on how much light has been absorbed by the material, this NTU unit will give. So for the, as per our Indian standard IS value for the drinking water, the NTU value should be 10 to 25 NTU. Okay, so if the water is in that range, then that is fine. That is fine for drinking water. That is our, as per our Indian standard. So if the water is consist of more particles, then that filter has to be done, that filtering system has to be designed, and after filtering, water, the NTU value should be in this range, then only the water sample will be passed for drinking, and then it will be consumed to the consumer. Now next is color. As I mentioned, this is one of second proper physical properties of water. So basically when the dissolved organic matters are like vegetations or something is decaying on a, or decaying on a, decomposes on a water, so it impacts the color of the water. It is measured by comparing the color of the water sample with the standard glass tube containing the solutions of different standard of color intensities. So how we can measure, so we know what is the actual color of water. Color is basically, actual color of water is colorless. I think it don't have any color. So but if any organic matters are present on a water, the color of the water will be changing, right? It will be something light change of color will be there. So one instrument is there, so in that basically different color bars are there. So first we have to keep our water sample in that glass tube, and we have to compare which color it is matching with this bar. So that unit IS value of this treated water should be 5 to 20, 5 to 25 cobalt unit. The unit of this colorimeter is basically cobalt unit. So basically we compare the water color with the cobalt meter color, and based on that we grade it. So as per our Indian standard for treated water, the cobalt unit should be 5 to 25 in that range. So now the next physical properties of water is the taste and odor. So as I mentioned earlier also, what is taste? Taste means once we take the water, so this is the basically the scale, you can say. Taste and odor means basically smell. If the water is composed of pollutants, it will produce a bad odor. Or originally water should be odorless and tasteless also. Fine. So odor depends on the contact of the simulating substance with the appropriate human receptor cell. So most organic and some other inorganic chemicals basically originated from the industry. Basically, it contributes taste and odor into the water. So so something like that scale will be there. In that we can find it out, this what taste and what odor the water is. Ideally water should be tasteless and odorless. So based on this scale, basically you are finding out how much pollutant is present in the water. If the odor is very high, then more number of pollutants are present in the water. So based on this scale you can find it out, the different uh, values of taste and odor. Now, the last physical properties of water is the temperature. As I mentioned, that if the more number of bacteria are present in the water, then what will happen? The temperature will increase in the water. Okay, so for the ideal drinking purpose, the water should be 5 to 12 degrees centigrade, in that range. Water, so above 25 degree water is not recommended for drinking. That is as per our Indian code. So we should drink water, or water temperature of water should be in this range. So if more temperatures are there, that means the water is more polluted in that we can interfere. Now the next characteristics of water is the chemical characteristics. So first attribute in the chemical characteristics is the pH. So pH, we drinking water pH, we know how to measure the pH of a soil, pH of a water, and for the drinking purpose pH should be 6.5 to 8.5, in that range. So pH value denotes basically whether the water is acidic or alkaline in nature. So water should not be more acidic, as well as water should not be in the more alkaline. So the actual range should be 6.5 to 8.5 for the drinking purpose. That is as per our Indian standard. So we know how to find that. We have performed this experiment during our, I think, first year chemistry classes. Also we have performed this pH calculation and how to do that. So now the next properties of water is acidity. The acidity of water is a measure of its capacity of neutralizing the bases. Acidity of water may cause, in presence of uncombined carbon dioxide, if present is there, of any or if any mineral acids are present in the water. Okay, that causes acidity in the water. So it is expressed as milligram per liter. So how much acid is there per liter in terms of calcium carbonate. Okay, so acidity is nothing but the representation of carbon dioxide or carbonic acid present in the water. So if water is more acidic, then again it will harm our uh, system, that our humans body system, as well as in some industries also. Sometimes if we distribute, so we should not always, there will be some limits in the acidity. So if it passes, then only we can tell it is a good water. Similarly, just like acidity, we have the alkalinity. If the pH value is high, then the water may be alkaline. So alkalinity also, if the alkalinity are present in the water in various forms, just like hydroxide alkalinity or carbonate bicarbonate alkalinity. So all these different alkalinity, if this type of salts are present in the water, this will produce the alkalinity. So we express alkalinity, that is in milligram per liter. In this unit, basically we express the alkalinity. So alkalinity is also an important parameter in evaluating the optimum coagulant dosage. So we'll discuss what is coagulant dosage. Because coagulant dosage, we add it, for the in the water treatment plant for the treatment purpose. So if a particular water is more alkaline, then we have to give more coagulant or less coagulant. So we have to find the optimum coagulant depending on the alkalinity as well as the acidity of the water. Now, next chemical properties of water is the hardness. So hardness, as we already know, that bicarbonate and carbonate and bicarbonate salts, if it is present on a water, it produces the hard water. So if the water consumes excessive soap to produce the foam, it is said to be hard, right? That's why you cannot use ocean water, because it is hard water, right? Hard water causes metal. So the principal hardness caused, you know are basically the calcium, magnesium, these all carbonate and bicarbonate. If this type of salts are present in the water, this causes the hardness of water. So total hardness of water is defined as sum of the calcium and the magnesium concentration, both are expressed in the calcium carbonate form. So m per milligram per liter, in this form, basically we find it out how much is the calcium carbonate and bicarbonate. Based on that, we tell whether it is hard water or it is less water. So again, hardness are basically two types of hardness are present in the water. One is temporary hardness, which can be reduced, which can be removed, but another is permanent hardness, which is very difficult to remove from the water. So for as per our IS value, so for drinking water, the carbonate or bicarbonate should be less than 300 milligram per liter. Then only we can use this water as a domestic purpose, or in the industry as well. So the next properties of chemical properties of water is the chloride. So how much chloride ion is present in the water, that also we have to find it out. So chloride ion may be present in combustion. It's one of the more cations of the calcium, magnesium, iron, or sodium, right? Calcium, magnesium, iron, or sodium's chlorine in chloride form, it may be dissolved in the water. So this also, so chlorides of these minerals are present in the water because of their high solubility in the water. So these elements, basically chlorides, will be present in the water. So as per our Indian standard, so this value, chloride value, should be in 250 by 2000 milligram per liter. So this chloride experience, so we have to perform these experiments in the chemistry lab, and we have to check all the parameters, how much it is, whether in this range or not. If it is more than this range, then again we have to treat we have to treat the water, and the range should be this one. Again, if it is below also, because chloride is sometimes it is required for our health also. That's why minimum chloride, minimum minerals should be present in the water. That's why 250 to 1000 milligram per liter is the ideal value for chloride present in the water. So similarly, sulfate. So sulfate occurs in water due to leaching of sulfate minerals and oxides of sulfate, right? Sulfates are actually present in the soil. From the soil, it dissolves into the water, and the sulfate associates are generally associated with calcium, magnesium, as well as the sodium ions. Right. So the a perfect limit. So sulfate should not be less than 50 milligram for the some industries, because industries they are using water for production of some products. So in that also sometimes they need sulfates should not be less than 50 milligram. So desirable limit for drinking water, it should be 1 milligram 150 milligram per liter, and maybe extend. So 150 to 400 is the desirable limit for the drinking water, and it shouldn't be less than 150, and it should be should not be more than 400 also, because a small quantity of sulfate is again it is required for our health purpose. These minerals will improve our immunity system as well. So that's why always minimum sulfide also should be there, and it should not be more excessive also. Then again it will create the disorder in our body system. Now the next uh, correct chemical characteristics of water is iron. So iron is also found on earth, and if you collect the water from the underground, that's why all the chemical things whatever we are discussing, or heavy metals, basically arsenic, iron, you will get it if you collect the water from the underground. So underground we have the iron minerals from there, basically irons are coming into the water. So irons are found on earth mainly because of insoluble ferric oxide. In the nature iron is present, but when it comes to in contact with water, it dissolves and to form the ferrous bicarbonate under the favorable condition, and this ferrous bicarbonate is oxidized into ferrite hydroxide, which is basically present in the iron. Okay, iron present in the water. So the iron quantity in the water also should not be too high, and that for the drinking purpose iron quantity should be 0.3 to 1 milligram per liter, and it should not be more than. So if you visit in some village areas where the water has been collected from the bore well, like underground water collection, there you will find near to this water supply, you will find this reddish color mark will be there. That is because of iron. If water is present, if iron is present in the water, those type of iron patches you will find near to the water supply plant, water supply stream, right? If you collect the normally irons are present if you collect the water from the underground source. Now the next is solids. Many solids will be present in a water in a dissolved form, or it may be in a suspended form also. So the total sum of a foreign matter present in the water, that we term it total solids. Total solid is the matter that remains as a residue after the evaporation of the sample, right? So now if you dry the sample, water will be evaporated, but the solids will be deposited at the bottom. Okay, so the total solid is consist of organic and as well as non-volatile inorganic solids are also there in the water. So as per our Indian standard, the acceptable limit is 500 milligram per liter, and the tolerable limit is 300 milligram per liter for the dissolved limit. So as per this is our IS, as per our IS code, so total solid should not be more than 500 milligram per liter. So we have to experiment here to find it out how much dissolved solid is present in the water, and based on that we can treat our water. Now the next chemical properties are the nitrates. So nitrate is also sometimes present in the water, and it is very much harmful for human bodies. But some industries they may need some quantity of nitrate present in the water. So nitrates you will find it in the surface water by leaching of fertilizer. See, nearby irrigation we use this fertilizer and all. So from these fertilizers, basically due because of rain, these fertilizers washed away and it deposits into the river or in the lakes. So from there, basically these nitrates are coming into the water. So presence of high concentrated nitrates is an indication of pollution, right? If you test a water chemical test the water sample, if you found more number of nitrates are present in the water, that means the more number of pollutions are there in the water, right? So the concentration of the nitrate should not be above 45 milligram causes disease, right? So it should be highest value is it should be less than 45 milligram per liter nitrate quantity. So now the last characteristics, that is the bacteriological characteristics of water. So at the beginning we discussed the water is composed of three types of characteristics, right? First one is bacteriological characteristics, and then we have the physical characteristics, chemical characteristics, and third one is bacteriological characteristics. So as bacteria, many pathogenic bacteria are present in the water, so we should not directly consume the water. So before consuming, we have to make sure that there is no pathogenic bacteria present in the water. So these different experiments are there to find it out how much bacteria are present in the water. So bacterial examination of water is very much important, since it indicates the degree of pollution. So what will happen is, if the pollutants are more in the water, what will happen? The quantity of bacteria also will increase, because it will have food in the water, and it will reproduce more number of bacteria, and ultimately so if you find it, if you experiment the bacterial characteristics of water, and if you find the more number of bacteria are present in the water, that means the water is very much pollutant. Okay, other suspended solids, nitrates, carbides, all these things are more number present in the water. So the pathogenic organisms causes waterborne diseases, and many non-pathogenic bacteria such as E. coli, as a member of coliform group, also lives in the water, right? But sometimes that coliform itself is not harmful, okay, but it is more resistant to the adverse condition that any other groups. So basically, we have to find it out. These experiments are there to find out how much bacteria are present in the water. The first one is the standard plate count test. So in that, what we do is, basically, we give the food at the maybe at the beginning of test, we perform how many bacteria are present in the water. Then after 3 days or after 5 days, if we count how many bacteria are there after 3 days. If the bacteria number increased exponentially, or in what sense it is increased, that is based on the pollution. If more pollution are present in the water, means more dissolved solids are present in the water, then the growth of bacteria also will be very high. So depending on this count test, this plate count, standard plate count test, we can get a estimation that how much quantity of pollutants are present in the water. Similarly, most probable number is another experiment we perform. Basically, in that E. coli bacteria are find it out. Mm, and similarly, membrane filter technique also, basically here a small filter membrane filter is there, so water is passed through the small filter, membrane filter, and their bacteria are basically filtered. So from these bacteria, now you give the food for the next few days, and how exponentially it grows, that actually depicts how much quantity of bacteria are present in the water, and how much pollutions are present in the water. So basically, what we once we collect the water, so once we collect the water from the river stream, or maybe any surface water, once we collect it through pipe, so we have to design, so water has to be passed to water treatment plant, right? Water plant. So then from water plant it goes to the household, right? Nearby household it goes. So this water treatment plant has different chambers, right? So each chamber will filter some portion. Some portion will filter the beginning large particles, suspended particles. Some will be filtering the dissolved particles on the water. Some will be removing the chloride. Some filter will be removing the nitrite. So each filter will be removing one portion from the sample, and ultimately the clean water will be distributed. So so in every test, every stage, basically we are performing all these experiments, and we are checking whether all the parameters are within the limit or not. So depending on the how much quantity of bacteria are present, or how much quantities of ions are present in the water, so the filtered this entire treatment plant design also will vary. So before designing this treatment plant, we have to first understand the qualities of water, means which quantity is more in the water, which quantity is less in the water. So depending on these quantities, we can design the filters. So in this lecture, basically we have seen the raw water collection, means from where we can collect the water, and what are the different properties of water, means what are the different characteristics of water. So in the next class, we'll be starting our design of this water treatment plant. So thank you.